Hey, guess what, students? This is the last video of summer school. This is lesson 6.6, System of Linear Equations. Okay, I bet you're excited to be almost done. Now, let's take a look. If you have your book with you, which you should by now, you probably should have figured that. I like you to have the book. It's on page 425. Okay, so oftentimes in mathematics, you have to take two different skills, one you learned in one region and one you learned in another, and you bring them together. That's what's happening here. So the first part of chapter 6, we learned about systems of equations. And then in a previous chapter, you learned about inequalities. So now we're learning about systems of inequalities. So we're bringing basically systems and inequalities together, okay? So in that respect, I want to talk about what do you do when you have two inequalities and you have a system to build, okay? So let's just review a little bit about systems in general. I want you to remember that linear systems have the point where the two lines meet as the solution. So I'm just going to draw just really quick. If you have a coordinate plane here, you have one line and you have another line. The spot where the two lines meet is considered the solution. Okay? However, in an inequality system, the solution is the area shaded by both inequalities. Now, if you remember when we made like a linear inequality, remember you shaded one side of the inequality. Well, if you have two lines, the inequality is going to be where, or the solution is going to be the spot that both lines are shaded, okay? So as you can see, I made a red line, I made a blue line, and I colored it in black just because I don't have, I think I do have a purple pen somewhere, but it wasn't handy. I shaded in black where both the blue and the red were shaded in together. I know it looks like some kind of like X-Men symbol or something. I don't know what I drew there, but the point is, with linear equation, the dot where the two lines meet is the solution. For a linear inequality, obviously there is a dot where the two lines meet. I'll give you that. But since we shade with an inequality, where the two shaded areas meet is, and in that case it's represented with black here, the shaded area represents the solution. I want to say this: any ordered pair that is in both shaded regions should be true in both inequalities. So if there's a point that's in this black area, we'll just say -2, 5, okay, just as an example. Whatever is in there, if you substitute it into the inequality, then you will actually get a true answer. Okay, so let me show you the steps here. So first, I am going to graph y is less than 2x minus 3. Okay, so first I'm going to start with the checking, is it in slope-intercept form? Yes, it is in slope-intercept form. So therefore I can pick -3 and make that my starting point. So I'm going to go on my graph here, and my first point is -3. Since it's also in slope-intercept form, I know that my slope is 2. So I'm just going to count up 1, 2, 1 over. Now I'm going up since my slope is also positive. 1, 2, 1 over. 1, 2 up, 1 over. So therefore I can make my line. Now I'm going to look at my inequality. Is it open or closed? Yes, Evelyn, you're correct. It is an open inequality. Okay, so an open inequality means I'm have a dashed line. Okay, now we're going to talk about shading, but I'm gonna hold off on shading until I have made the second one. So now I have 2x plus y is greater than 2. Now, this is not in slope-intercept form, so what I'm going to do is I'm going to subtract 2x to both sides of my inequality. So now, if I do that, the 2x's here cancel out, and I have y is greater than 2 minus 2x. So to put it in slope-intercept form correctly, I just want to say y is greater than negative 2x plus 2. Simply all I did was just switch the order of these two items so that it's written in the correct form. Okay, you don't have to do that, but it just kind of makes it easier to not get confused unless you like do this all the time, you know, like I do, but it's because I'm a math teacher. What can I say? All right, so y is greater than negative 2x plus 2. So plus 2 is my starting point for the blue line. Okay, now negative 2 means that my slope is downward. So I go, so negative 2 would be negative 2 over 1. So I go down 1, 2 over 1. Okay, down 2 over 1, down 2 over 1. Okay, so I've got 4 points. I think that's enough to establish a line. So let me look at my inequality, open or closed. Isai, you're right, that is an open inequality. So my line needs to be dashed. So I've got a dashed line here. Okay, so now I've made both of my lines. So let's take a look. Now, if I look at it, actually, let me start with the red line. Okay, the red line was y is less than 2x minus 3. Okay, so since y is less than, I shade everything below the line. So that means that if this is my line, everything below it should be shaded. Okay, so I'm going to go ahead and shade. But there's also this blue line here. Okay, but I'll go ahead and I'll just shade everything there anyways. Now the blue line ends up being y is greater than negative 2x plus 2. So since it's greater than, it'll be everything that's above this line should be shaded. Okay. Now, as you can see, there's the middle section, which happens to be shaded both. Now, just for our purposes in the color code again, blue and yellow make green, so I'm going to shade the area that both are shaded as green. Okay, so any point in this green region is going to actually make both of these true. So let's come up with a point. Now normally I say you do the point 0, 0. Now 0, 0, as we can see, because I've already shaded, is false for both. So I'm just going to pick a point here that's convenient for me. So let's see. 1, 2, 3, 4. So we'll say 5 for the x value, and we'll just say 1 for the y value. Okay? So I'm just picking a point that I'm fairly certain is in here. Now what I want to do is I want to substitute that point into both equations. So let me go down here to the bottom, and I'm going to rewrite both inequalities. Forgive me, I said equations earlier, common mistake. Hopefully you knew what I was talking about. Okay, so I'm going to substitute the value 5, 1, 5, 5, 1, 1 into both inequalities. Okay. Give me just a minute to get that figured out. Okay, now this should make both inequalities true, so let's go ahead and do the work. 2 times 5 is 10. 10 minus 3 is 7. So the answer here is 1 less than 7. Yes, that is true. So I can check that off. Now let's do the other one. Negative 2 times 5 is negative 10. Negative 10 plus 2 would be negative 8. So is 1 greater than negative 8? Yes, that is true. 1 is greater than negative 8. So that's how you solve a system of inequalities. Now, I can end the video here, but I just wanted to go over, that was problem 1, by the way, on page 425. Wanted to just take a quick look at problem 2 here, just so you can kind of get the idea, okay? So what system of inequalities is represented by the graph below? Okay, so in this particular one, they did the shading wrong on purpose so that you would have to kind of figure it out. Now, the red boundary line is y is equal to negative 1/2 x plus 5. Okay, so in the inequality, that would end up being y is less than negative 1/2 x plus 5. So since it's less than symbol, we have a dotted line. The blue boundary line is y is equal to x minus 1. So therefore, the inequality would y would be greater than or equal to x minus 1. Okay, so since that's a closed inequality, we have a closed line. Okay, now, since that one's greater than, you shade everything above. And since that one's less than, you shade everything below. And then the area here where it is green is shaded in both. Okay, hope that helps you to understand this process. You can review the video or back it up if you need to. Thank you much. And bye-bye, since this is our last video. Glad to have taught you summer school.